This is for page 23 and 24. It's kind of similar to what we did last class, but in these, the tokens that are taken from the bag are not replaced in the bag. So the probabilities in the second trial are going to be different than the probabilities in the first trial because you're missing the token that was taken out the first trial. Okay, so you got a bag containing 6 red and 5 blue counters. One is chosen at random, its color is noted, and then it is not put back in the bag, and then the second counter is noted. So we're going to draw a probability tree for that. And in the first trial, we can see that we chose a red or blue token. And then in the second trial, we also choose a red or blue token. But the probability is going to change from the first trial to the second trial, because in the first trial, we have 6 reds and 5 blues in the bag. So there's a 6 out of 11 probability that you're going to choose red, and a 5 out of 11 probability that you're going to choose blue. If you choose red the first time, then we no longer have 6 reds in the bag. We only have 5. So the probability that you would choose red the second trial, the numerator would be 5. What about the denominator? Well, the denominator is also less because the first trial you chose a token and you didn't put it back. So now it's 5 out of 10 instead of 6 out of 11. What about for blue? Well, blue would just be the opposite of that. It would be 5 out of 10 also. Okay. Now, if you choose a blue first, that means that, again, you have just 10 tokens remaining, so the denominator would be 10. But now you have 5 reds remaining because you have 6 reds remaining because you chose a blue out, right? And then since you had 5 blues, but you chose a blue, then there's only 4 blues remaining. So you can see that in the second trial, the probabilities change. First, the denominator, instead of 11, is now 10 because you have 1 less token. And in the case that you chose a red first, you now have 1 less red. In the case that you chose blue first, now you have 1 less blue. Now, if you want to find out the probability of each combination, like for example, what's the probability of red, red? Well, that would be 6 over 11 times 5 over 10. So that probability would be 30 over 110. Red, blue, 6 over 11 times 5 over 10, so it would be the same, 30 over 110. Blue, red, that would be 5 over 11 times 6 out of 10, that would also be 30 out of 110. And then finally, blue, blue, it would be 5 over 11 times 4 over 10, so that would be 20 over 110. Okay? As you can see, if you add up these probabilities here, these 4 probabilities, they add up to 110 over 110, which is probability 1. So that makes sense. The probability of any of these happening total would be 1. Okay, let's look at the questions now. So find the probability that exactly 1 red counter is chosen. That would be this event here and this event here, because red, blue, and blue, red are the only possibilities where one red is chosen. Red, red, 2 reds are chosen, so that doesn't count. So you just add up 30 over 110 with 30 over 110, you get 60 over 110. Find the probability that at least 1 blue counter is chosen. Well, that's only red, blue, and blue, red also, because blue, blue is 2 blues, not 1 blue. So that would also be the exact same answer, 60 over 110. Find the probability that 1 of each color is chosen. 1 blue and 1 red in any order. So that would be red, blue, or blue, red. Same thing again, 60 over 110. Now let's look at D and E, which are conditional probabilities. Conditional probabilities are a little bit different than the other probabilities we've done, because conditional probability means that we're given that one event happens, and based on that, the probability that the second event has happened is different than before. Usually it's more likely, okay? So for example, like given that EAC has won its first game in Hunshul, what's the probability that they're going to win the championship? Okay, once you know that they have won the first game, then the probability that they're going to be champions is slightly more, right? Something like that. Okay, so here we are. We're going to use this formula to figure this out. The probability that A happens, given that B has already happened, is the probability that A and B happen divided by the probability that B happens. Okay, so for part D, the two events are probability B is, or the B event is one of each color is chosen. The A event is blue is chosen on the second pick. Okay, so we want to figure out the probability that A happens given that B has already happened. First of all, let's figure out what the probability of B is, and we've marked it with the yellow highlighter. So what's the probability that one of each color is chosen? Well, that would be this event and this event, right? The one of each color was chosen. Hey, we already calculated that. We already figured out that that was 60 over 110. So we'll put 60 over 110. What about the probability that that a blue is chosen on the second pick and that one of each color was already chosen? So the blue is chosen on the second pick in two cases, in this case and in this case. But the bottom case, blue was chosen in the first pick also, so the combination chosen is blue-blue. If they're saying that A has also happened, or that B has also happened, one of each color is chosen, then the only possibility is red-blue. So we're going to mark that with the green highlighter. Okay, so that event is the only one that classifies as the probability of A intersect B. So that would be 30 over 110. Now remember that you can cancel these out. So that gives you 30 over 60, which is probability 1/2, right? So you're done with that. So the probability that one of each color is given that that one of each color has been chosen, so it's red blue or blue red. What's the chance that blue was chosen on the second pick? So that's only red blue. So the probability of red blue divided by the probability of red blue blue red. Okay, 30 over 60. All right, E. If at least one blue was chosen, what is the probability that blue was chosen on the first pick? Okay, so we're going to mark the probability that blue, at least one blue was chosen. We're going to mark that with pink. So at least one blue is chosen. So that would be this, this, and this. So the probability of B is 30 plus 30 plus 20, which is 80 divided by 110. And then what about the probability of orange? Orange is that blue was chosen on the first pick and at least one blue was chosen. So that would be blue chosen on the first pick. So that would be this one and this one. So that would be 30 plus 20, 50 over 110. And so if you divide that out, you would get 50 over 80. Okay, now page 24, problem 3. To get to school, I can take one of two routes, Kent Ridge or Sunnyvale. So I mark in the first decision I have either Kent or Sunnyvale, and if I take Kent Ridge route on average 3 times in a 5-day week, so the probability that I take Kent Ridge is 3 out of 5, and the probability that I take Sunnyvale is 2 out of 5. If I take this route, Kent Ridge, the probability that I'm delayed is 0.25. So that means the probability that I'm on time is 0.75. If I take Sunnyvale, the probability that I'm delayed is 0.5. Okay. Draw a tree diagram that shows my journey to school. Find the probability that I get delayed. Let's see. The 4 possibilities are I take Kent and I'm delayed, I take Kent and I'm on time, I take Sunnyvale, I'm delayed, and I take Sunnyvale and I'm on time. The probability of each one, let's calculate that. So 3 divided by 5 is actually the same thing as 0.6. And 2 divided by 5 is actually the same thing as 0.4. So we'll write those down too. The probability that I'm going to be delayed taking Kent is 0.15. You multiply together 0.6 and 0.25. The probability that I take Kent and I'm on time is 0.6 times 0.75. I gotta do that on my calculator. 0.45. The probability that I take Sunnyvale and I'm delayed is 0.2. 0.4 times 0.5 is 0.2. The probability I take Sunnyvale and I'm on time is also 0.2. Now let's check to see if all those add up to 1. So 0.15 plus 0.45 plus 0.2 plus 0.2. Yes, that adds up to 1.0. Okay? All right, now find the probability, part A says find the probability that I get delayed. So that would be this probability plus this probability, the two delay possibilities. So that would be 0.15 plus 0.12. So that would be 0.35. Find the probability that I go by Sunnyvale and I do not get delayed. So Sunnyvale on time. That would just be this one, right? That would be 0.2. Given that I am delayed, what is the probability that I went via Kent Ridge? Okay, so let's go down here. Remember the probability formula for conditional probability. So the event A is that I went via Kent Ridge. The event B is that I'm delayed, because given that I'm delayed, what's the probability that I went by Kent Ridge? So to find that, I just need to write the probability of A intersect B over the probability of B. So let's do probability of B first. What is the probability that I am delayed? We already figured that out. It's 0.35. What is the probability that I am delayed and I went via Kent Ridge? Okay, so that would just be Kent delayed, so that would be 0.15. Okay, so 15 over 35. All right, now let's do the next one. Given that I am not delayed, what is the probability that I went via Sunnyvale? So B would be on time, and A would be Sunnyvale. So what's the probability that I'm on time? Well, the probability that I'm on time is just the opposite of the probability that I'm delayed. So it would be, let's see, these two events. It would be this on time and this on time. So it would be 0.45 plus 0.2. So that would be 0.65. Probability that I went on Sunnyvale and I'm on time. So that would be SOT, right? So that would be this one here, SOT. That would be 0.2. So the probability is 20 over 65. Remember, 0.2 is the same thing as 0.20. Okay, let's move on to number 5. There are 8 identical discs in the bag, 5 of which are black and the other 3 are red. The random experiment is to choose a disc at random from the bag. Do not return the disc to the bag. Then choose a second disc from the bag. Find the probability that the second disc chosen is red. So if 5 are black in the first trial and the other 3 are red, that means the chance that you pick out a black one is 5 out of a total of 8 discs. So 5 of 8 chance to get a black disc. Then to choose a red disc, it would be the opposite. It would be 3 over 8. What about the second trial? Now, if the first time you chose a black disc, there is now not 5 black discs left. Now there's 4 black discs. And there's only 7 total discs left. So the chance you could get a black disc the second time would be 4 out of 7. The denominator for the second time would always be over 7. And what is the chance that you would get a red disc the second time? Well, you still have 3 red discs left after the first trial because you chose a black disc the first time, so it would be 3 out of 7. Now let's take the case where you chose red the first time. Now you still have 5 black discs in the bag, so there's still a 5 out of 7 chance you're going to choose a black disc. Now you have a opposite chance of choosing the red disc, 2 out of 7, because you only have 2 red discs left. You chose one of the 3 red discs on the first trial. Now to find the probability of each case, so like the first one would be black black, second one would be black red, third one would be red black, last one would be red red. So black black would be 5 over 8 times 4 over 7, it would be 20 over 56. 5 over 8 times 3 out of 7, it would be 15 over 56. 3 out of 8 over 5 over 7, that would be 35, that would be 15 out of 56. And red would be 3 over 8 times 2 out of 7, it would be 6 out of 56. So let's check to see if those add up to a total of 1 over 1. 20 plus 15 would be 35, plus another 15 would be 50, and then add 6, 56. Yeah, so 56 out of 56 would be the total, which is just 1, so that makes sense. Okay, now let's go back to the question. Find the probability that the second disk chosen is red. Okay, the probability that the second disk chosen is red, we would want to look only at, let's see, second disk chosen is red, so it would be that and that. So we're going to add this probability with this probability. So that would be 15 over 56 plus 6 over 56, which is equal to 21 over 56. And that's all they were asking, right?